If you haven't done so yet, please pause the video and try to answer the question before listening on. In the first part, we are asked to determine the mass of methane gas that is produced. And if you're unsure of where to start this problem, it's usually a good idea to begin by simply writing down the given quantity. So we'll just come over here and we will write down 82.4 kilojoules. Now, this is basically going to be a question in which we set up a series of conversion factors. And we know that when we do that, whatever unit is written first must be written in the denominator of that first conversion factor. Now, what might be challenging is to fill in the rest of this conversion factor. In terms of the number of kilojoules, the only other number that's given to us in the problem in kilojoules is this positive 252.8. So we know that we can write that number in the denominator of the conversion. In the numerator, what we're allowed to do is look at the balanced equation and write the number of moles of any of the molecules present. Now, the question is asking for a mass of methane gas. Methane has a molecular formula of ch4. So what we want to do is go and look at the coefficient of the ch4. And we're able to write 2 moles of ch4, since the coefficient in a balanced reaction always represents the number of moles. Now, it didn't ask for the number of moles of ch4, it wants the mass. So we'll have to set up another conversion factor. Since we have moles of ch4 in the numerator, we know that moles of ch4 has to go in the denominator. And we know from earlier chapters that there's a nice way to travel from moles of ch4 to grams of ch4. And we do that by looking up the molecular mass of ch4 using our periodic table. Now, carbon has a molecular mass of 12. Hydrogen has a molecular mass of just 1, and there are 4 hydrogens. So that's going to give us 4. The total molecular mass, therefore, will be 16 grams. So we can confidently write 16 grams of CH4 is present in 1 mole of CH4. Now, after canceling the kilojoules as well as the moles of CH4, we are indeed left with grams of CH4, which is exactly what the question was asking for. Let's pick up our calculators and process this computation. And when we do that, we should get approximately 10.4 grams of CH4 produced. And so this is the correct answer to the first part of the question. In the second question, we are asked to determine the number of kilojoules of heat that are released when 38.9 grams of methane reacts completely to form the methanol at constant pressure. Again, if you're not sure where to start, it's always a good idea to simply write down the given quantity. So we'll come down here and we'll write down 38.9 grams of CH4. We're going to set up a series of conversions. We know that since we have grams of CH4 as the given quantity, we're going to have to place grams of CH4 in the denominator. Now we can convert from grams of CH4 into moles of CH4 because we know from the first part that 1 mole of CH4 corresponds to 16 grams of CH4. Our next conversion, looking at moles of CH4 in the numerator, will require us to write moles of CH4 in the denominator. Remember that the question is asking for kilojoules of heat. And so if we go to the balanced reaction, we can see that 2 moles of CH4 releases 252.8 kilojoules. So we can actually write a conversion between the moles of CH4 and the number of kilojoules of heat released based on the given reaction and the given delta H. Now, if we look carefully, the grams of CH4 will cancel and the moles of CH4 will cancel, leaving us with kilojoules, which is exactly what the second question was asking. We simply have to pick up our calculator and process this computation. And when we do so, we get approximately 307 kilojoules as the answer to the second part of the question. Thanks for taking the time to watch the video. If you liked it, please click the thumbs up icon and also subscribe to the channel. And remember that you can send in your own question to the email address shown on the screen, and I'll do my best to post an answer to it on YouTube.